In number 2, we have to figure out the coordinates of the point of intersection of two lines. So first of all, just check that they do intersect, and our direction vectors not being collinear tell us that they will intersect. So the easiest way to figure out an intersection is by changing your equations into parametric form. So x equals 1 plus 3t. If we do the same equation for the next one, x equals negative 2 plus 1s. Y's is negative 1 plus 2t, and y is negative 3 plus 3s. And the z's for the first one, 1 plus t, and the next one, z is just 3s. Okay, if these are going to intersect, which we're told they do, then that means these two things have to be equal at some point. So we'll set them up. Let's make the x's equal. And to make it easier to work with, we'll put all the s's on the right side and the t's. So bring this over here. I'll bring the 2 backwards. And we'll get 3. We'll do the next thing, same idea for the y's. So negative 1 plus 2t and negative 3 plus 3s. So again, if we put the s's first, then the t's, and bring the 3 there side, we get 2. And if you wanted to, you could do the same thing as the z's. And so 1 is 3s minus t. So you have a choice here. You got to pick one set of equations, solve them, and then you can use the third as your check. So I think it makes sense to put this one underneath here because our s's are both the same. And they also have the same sign, so we're going to subtract them. So 1 minus 2 is negative 1. 3 minus 3, there's no s's. And negative 1t minus negative 2t just gives us t. So we've solved for t. If we go back to one of our initial equations, for instance that one, we can say that 3s minus negative 1, and we're going to solve this for s. We'll get 1 equals 3s plus 1, or in other words, 1 minus 1. 1 minus 1 is 3s, so s is 0. And so we want to do the check. So go back to your third equation. Oops. Use that as our check. So 3 should equal s. S is 0. Minus 3, t is negative 1. And what do we get? Yeah, sure enough, we get 3 is 3. Okay, so here's our parameters that creates a point of intersection. Our question now is, what's the point? So, your choice, pick any of your x's, which is like 1 plus 3t, but we know what t is, right? So 1 plus 3 times negative 1. In other words, x is negative 2. Y, your choice, you get to pick the s's. So I'm going to use the s one this time, which is kind of nicer, right? Because s is 0, so I just get negative 3. And z is 3 times s, which is 3 times 0, so z is 0. So therefore, our POI is negative 2, negative 3, and 0. Okay, there's all part A. Part B, determine the distance from R1 to the line given by this. So, because this is R3, we want to find a line in R3. We have to, distance to a line in R3. We have to know our normal. To know our normal, sorry, I was actually looking at the wrong question for a second there. Okay, so we want to find the distance from R1, okay, which is this line to this line. So let's rewrite this second line here just in vector form for a second. So 4, 1, and 0 plus t, negative 6, negative 4, negative 2, which if you wanted to, you can think of this scalar multiples. Divide it all by negative 2. What do we get? We get 3, 2, and 1. So really it's the distance between two parallel lines. How do we find the distance between two parallel lines? Well, for part B, we take one of our lines, so R1, which was 1, negative 1, 1, t, 3, 2, and 1. And we figure out the distance between that line and a point on the other line. So our point is 410. 410. So our distance equation is, well, we need to know our normal um, between 2 points. So to do our distance, we need to take the direction number 1 that we have and figure out a second direction. Okay, a second direction we can call the point A to B. So if we do our vector subtraction, A minus B will give us 3, 2, and negative 1. Okay, so then when I go to do my normal, my cross product, I now have, hang on, let me erase this for a second. I have one direction, which is T, crossing A, B. We know our distance will be the magnitude of that over the magnitude of our initial direction, which is T. Okay, so T is 2, 1, 3, 2, and then 2, negative 1, 3, 2. So we're going to do the magnitude. Don't forget to do the magnitude after, okay? Negative 2 minus 2, and 3 minus negative 3, and 6 minus 6. There's our cross product over the root of 3 squared plus 2 squared plus 1 squared. So on top, we're doing the square root of negative 4 squared plus 6 squared plus 0 squared. On the bottom, we end up with the square root of 14. So on top, we end up with 36 and 16 makes root 52 over root 14. And it doesn't divide nicely, so you can leave it like that, or you can change it into decimals. Okay, and there's your distance.